Your block is down here. No, it's not. Mine's over here. So he says, really? I said, yeah. So anyway, this is actually the block that I talked about in my book, and I hadn't even stumbled across the block that Stephen had until he showed it to me. But what I had done is determined that there were clear signs of machining. I mean, they had to have had some kind of precision three-axis control, at least three-axis control, to create this block. The contour is regular. The contour is replicated around the block. It has features that are very difficult to produce, and it has features that are quite common, a common manufacturing design today. And basically what I'm talking about is this feature right here, where you have a groove, almost a groove down in near the face here. But this piece of forming wax, and I demonstrated this when we went to the Giza Plateau a couple of weeks ago with the Body, Mind, Spirit journeyers, and showed them again. Took a piece of forming wax, pressed it into the corner, so that I had I had the impression of the radius in this corner right here, and then I showed them around the different parts of the block that the radius was consistent all the way around. Now, what I'm talking about this is like an engineering drawing of that. You have a top view, front view, a section of it. This contour is replicated with precision across the entire length of the block. And using a precision parallel on the top of the block over 12 inches, it was accurate to within a thousandth of an inch. But I would say overall, because there did seem to be some cracking and some flaws in it, I would say that overall it's probably within 5/1000ths of an inch of being true to form. This feature right here is common, and basically what we do here, we only do this if we want to cut the block efficiently, and we want to use a larger tool bit to cut the block with a larger radius, but we have another piece that we want to put on there with a smaller radius to fit in the corner. And when you're working things out to a very, very small radius, it takes exponentially longer period of time to do that. So it's just an efficient way of creating an object mechanically in a practical way. And it's quite common in engineering today. We will look at some of the precision crafted bowls in the Cairo Museum while we were there. Incredibly crafted, very precise, perfectly balanced. That's the schist bowl that Stephen was talking about. Sophisticated lathe work. They cannot create these things using chisels, and the machining marks on them are so clear, so evident. I see them every day. I've lived with them for years. I recognize them. This is a metal artifact that we looked at while we were in the Cairo Museum. And, it's like most people see this and they go, what is that? I took it back. I created a drawing of it because I didn't get a very good photograph, and I created a drawing of its features, and I went to our chief engineer at the company I work for, and I says, hey, Alan, what do you think this is? And he said, well, it looks like a transition duct. And basically a transition duct is a device that they put in an aircraft engine that redirects airflow or takes air or some kind of a fluid or a liquid from one place to another. Mixes it. You have a hole in this side right here, and it's it was just an amazing piece of artifact, and it's kind of like where did it come from? Here we are at Abu Ghraib, the hemispherical blocks that Stephen was talking about, made out of alabaster with the holes in them. And there's a lot of these, and it seems like the Sun Temple was actually surrounded by these. It had them layered around there. And that's the altar that Stephen was looking at, the so-called altar. Yeah, I mean, Stephen was right. This material is very friable. It breaks easily. It cracks easily. You're not going to create something like that by pounding on it with a chisel. It just doesn't work. And then when we look closer at it, we can see, if we look in the corners, we can see that we do have the evidence of tool marks, circular tool marks in these corners. So it's a very interesting artifact. It's massive. It's a massive piece of stone. I mean, just one of those pieces of stone is incredibly huge. But this alabaster, and this is like you can see where the sedimentary layers are on the alabaster. And they make beautiful bowls out of alabaster, translucent, beautiful bowls. And so how did they do all this, And, just ask any Egyptologist, except Stephen. He's not a real Egyptologist anyway, but I think I was sold a bill of goods back in '95. But they will tell you, I went to the Cairo Museum in '86, and I said, well, how did they build the pyramids? And he said, well, come here, I'll show you the tools that they use. And so he showed me this case with these copper implements. He said, see, these are the tools that they built the pyramids out of. And I'm like, oh, okay. No, we won't get there yet. But anyway, they have two cases, about 12 copper chisels, and with these 12 copper chisels, they created miracles. And I don't think they actually attacked the stone with them. I think they used them as wands, and it's the only way. I mean, that makes more sense to me. I don't know about you, but it does make more sense to me that they were using them as wands and miraculously creating those blocks. But this Egyptologist, he was very friendly, and I said, well, what about the granite? You can't cut granite using copper chisels. And he said, he says, but you need to go to Aswan and look at the unfinished obelisk. Come, I take you to the travel agency. So he took me over to the travel agency and made sure that I bought 2 tickets to Aswan. I realized later, after learning some of the habits and customs of Egypt, why he had to make sure that he was there taking care of me. And I'm sure he paid a visit to them later, or received something in the mail. But anyway, I went to Aswan. It was very educational. It was great being at the unfinished obelisk. It was great being there again with Stephen. And I was hopefully going to have some photographs of the latest trip, but time got away. Time and sickness got a hold of me. But this was in 1999, and I'm wearing Alan Alford's hat there. And I'm going to have to send it back to him one of these days. But this is inside the so-called box in or so-called sarcophagus, the box in Khafra's pyramid. And in '95, I didn't have a square. I didn't have a precision square. I had a very precise surface gauge, and I noted on the inside of the box just how perfect and how precise the surfaces were. And so I wondered how square the corners were. And here I am exclaiming bloody hell, because I'm like, whoa, bloody hell. This is absolutely incredible work. How do they do this? And you don't create that kind of perfection or squareness in a corner just by measuring from corner to corner. I mean, theoretically, if you measure from corner to corner, make sure they're equal, you're supposed to be square. But to create that precision, you cannot do that unless you use instruments that you can measure to within 1,000th of an inch. And then you won't measure to the sharp corner because you won't know how sharp it is. You'd have to have some kind of a gauge to fit on the surfaces that would not take into account the corner. I mean, it's very, very particular work. It's very involved, and people train for years and years to create these kind of artifacts. That's a wax impression of the corner, and the corners are very sharp. And that's another feature of these ancient boxes, is how sharp those corners were. Now, this is a box that you could create with a dolerite pounder, and this is the kind of technology that the Egyptologists claim that the ancient Egyptians had. And so, yeah, you'd be perfectly capable of creating something rough like that with a $8 pounder. Certainly not what I just showed you. Now, these, for anybody of my particular bent, training, experience in life,